those questions are is about the energy and work, right? The work is Fs, where S is the distance, the displacement between A and B, and F is the force acting on the same direction. So the first question is constant force. This object is moving from origin to point 6, -8. So this object moves from here to here. And then there is a constant force on the positive x direction, which is 12 Newton. This object is 4 kilogram. Okay. And the question is asking what's the how much work is done by the given force. First thing you need to find the component of this force along this displacement direction, right? So we need the theta here. And we know here is 6, here is 6, here is 8. So tangent theta is 8/6, right? So for this question, we'll get cosine theta 6/10, which is 3/5. You can calculate based on that.
But wouldn't it, because it's moving along the positive x direction, wouldn't it be 12 times 6? It'd be plus 72, right? Isn't it easier to just do that? Because it's moving along the positive x direction, so we don't have to even look at the -8. Can we just do the work is equals to the force, which is 12
Yeah, you can also do that.
times 6? Because it's moving in the x direction.
6 is 72. How much work is done? 72. Yeah, you're right. And it's easier. Yeah. Because you know, a lot of times if you need to, you just use cosine theta.
Right.
And if it's in this case, yeah, 72. 6, that's 12, and here is 6, 72. You're right. Just a lot faster. Okay. And the second question is 5 kilogram object is pulled along a horizontal surface at a constant speed. So constant by a 415 Newton force. Here is 20 degrees. How much work is done by this force as the object move 6 meters? Okay, so you just find the component along the horizontal line. So it's cosine 20 degrees times the distance, which is 6 meters. Then you got 84.57, which is C, right?
Yep.
And then the third one is from a well. Man is lifting an object which is 2 kilograms from the bottom at a constant speed, 2 meters per second for 5 seconds. Analyze this object. So there is a gravity, and there is a lifting force, like this human. So, and it should be equal, because the speed is constant. So this force is equal to mg. And then you calculate the distance in 5 seconds. 5 seconds, how far it moves. Times 5 seconds will be 10 meters. So this force acting on this object for 10 meters, right? And then the work will be F times S, which is 19.6 Newton times 10 meter. It's 19.
To get the distance, it would be the velocity times the time.
Yes.
That's for distance?
Yes.
Okay.
So, which is around 0.2 kilojoule. And then number 4. A block is pushed across a rough surface from A to B by a force 5.4 Newton. The magnitude of the force of friction on the block is 1.2 Newton. And here is 0.5 meter. If the kinetic energy at A is 4 and B is 5.6, how much work is done on the block by the force P between A and B? Okay. So we know how much work the fraction did is because it's negative, right? 1.2 times. And we know the change of the energy. So the work done by this force plus the work done by the friction, it should be the change of the energy, right?
Okay.
According to conservation of the energy should be equal from the beginning and the end. So it's 5.6 joule. It's 1.6. Should be 2.2 for this force. You understand this one? So, for example, an object, there are several forces. F1, F2, maybe even F3. And then it moved from A to B with which is has a distance s, and we know the energy here is energy